Hello and good afternoon, everybody. Welcome to the Homework Helper for 2.4. We're going to be comparing arithmetic and geometric sequences in this very first section of the homework. And so it kind of gives us an example here of what we're doing, where we're going to be adding a to each step, and then in this case we're going to be multiplying by 3. And what you'll notice is that we start at the same place and we end at the same place. We start at the same place, we end at the same place. But one, we're trying to figure out how it works geometrically, and the other one we're trying to figure out how it works arithmetically. So to do this, I like to build little tiny equations. So when I look at this here, I know that I'm adding a difference, I'm adding a difference, I'm adding a difference, I'm adding a difference. So I have 3 plus 1, 2, 3, 4 differences. Whoops, these D's are a little sloppy. It's kind of the end of the day here. And that's going to equal 48. So now I just need to simplify this. This is 3 plus 1, 2, 3, 4 D's. And that's going to equal 48. If I subtract 3, I have 4D equals, what is that, 45? And I divide by 4, I have D equals 11.25. So I know I'm adding, whoops, I didn't show that to you. Uh-oh, let's show this. So I know that I'm adding 11.25 at each step. So when I do that, I get 14.25, and then I add 11.25. So I get 25.5, I get 36.75, and then that takes me all the way up to 48. Kind of cool. And now we're going to do it with the geometric, except this time, instead of adding a difference, I'm multiplying by a ratio, multiplying by a ratio, multiplying by a ratio, multiplying by a ratio. So this ends up being 3 times 1, 2, 3, 4 ratios is going to equal 48. And so I can simplify this to 3r to the 4th power equals 48. Cool. So now I divide by 3, so I get r to the 4th power equals, I don't know what this is off the top of my head, 48 divided by 3 is 16. And now I just need the 4th root of 16. The 4th root of 16. Which I'm pretty sure is 2, but let me prove it. So this is going to be 8 and 2, and that's going to be 4 and 2, and that's going to be 2 and 2. So I have 1, 2, 3, 4 2's. So yeah, definitely equals 2. So now when I look at this geometric, and you could just plug that into your calculator too. I just decided to do it the hard way. 3 times 2 is 6, times 2 is 12, times 2 is 24, times 2 is 48. And so you'll do that for each of these sequences. You'll do both the arithmetic and the geometric and kind of see how it changes from one step to another. Like from here, this second step is way below the arithmetic, and it's way below the arithmetic the entire time, but it catches up to it. So what we see is in these areas in between where it starts someplace and it ends someplace, the arithmetic is actually going to be higher than the geometric. But we know that afterwards the geometric is going to start taking over, because here, like let's look at this one here. When we add that next term, which was 11.25, we get 59.25. But when we multiply by 2, we get, what is that, 96? We get a huge number. So we can see that it starts to overtake it at this point where they're equal to each other. All right. When we look at here, all right, we're asking about different types of numbers again. So we're going to distinguish specifically between linear or exponential functions. So if a relationship is modeled with continuous functions, which of the domains choices is a possibility? Now I kind of went over this, but I want to make sure we have everything. R means real numbers. W means whole numbers, etc. So the set of x where x is greater than or equal to 0, all real numbers, that's going to be a continuous, because every single real number, this is going to include numbers like 0.5 and all that sort of stuff. Whole is only 1, 2, 3, 4, so that can't be continuous, right? Z is rational numbers, right? Well, I don't think I ever went over that, actually. I probably should have. That means rational numbers, and n means natural numbers. which are the whole numbers that we count. And so these are all things that have gaps in them, whereas real numbers do not. So kind of keep that in mind when we go through that. All right. And don't stress out too much about that one. We'll go over that more later. And then this is more of just figuring that out. And then finally, we're being asked to write explicit equations for linear and exponential models. So what we have to do is we have to figure out whether or not it's linear or exponential. And here, let's see if this is linear. So this could be a minus 7, minus 7. Okay, this is linear. Great. So I know that my rate of change is negative 7. So y equals negative 7x. And now I got to figure out what my 0th term was. Well, it's kind of hard to tell because I only have the second term. But if I go up 1 to the first term, that would be a 3. And if I go to the 0th term, that would be a 10. So I know that it's 7x plus 10. Here, I see from each step, I'm multiplying by 5, multiplying by 5, multiplying by 5. So I can write an equation. I know that y is going to equal my 0th term, which was 2, times my rate, 5 to the x power. And there we go. So that's what we're looking for here. Now when we get to these graphs, you know, for some of the lines, you can do y equals mx plus b. Oops, let me do it over here so we can actually see it. Y equals mx plus b, where m is the slope and b is the y-intercept. Or you can kind of make these little charts, find places where it crosses exactly, and see what that is. At 0, it's 2, and then we see that that we change by each time we go forward. It looks like we subtract a third. So this is going to be negative 1/3 x plus 2, y equals, etc., etc. Okay, guys, good luck with these. If you have any questions, we'll go over this tomorrow. There's a couple curveballs here that maybe I didn't set you up too well for. So we'll go over some of these tomorrow and then go from there. Have a lovely day.